Consider a situation that I want to buy a laptop, let's say. So I'll go to Walmart and maybe write here MacBook on top in the search. So these are the search results, right? As you can observe here. So if you can observe, let's say if I search for the operating systems, as you can observe here. So in this Apple, we have Mac OS, right? So let me just go for other laptops. I'll just search for some other laptops. So let me go for this one, right? So if I search for the operating system again, right? So this will contain Windows for sure. This machine will contain Windows laptop, as you can see, it is written here, right? So this is the Windows machine. Similarly, I can have Ubuntu Linux and so on. So by this, I just wanted to tell you that if you buy any piece of hardware, be it your mobile phone or laptops, desktops, so these hardware is barely useful without an operating system. So that much important this piece of software is, right? So it's very clear we are going to talk about operating systems. So it is an intermediary, right? What is an operating system? It acts as an interface or intermediary between the user of a computer and the computer hardware, right? So since you all have written, you might have all written C programs. So I'll show you one C program over here, right? So what I'll do, I'll just write here printf, and here I'll write hello. Let's say some statements are there. I'm writing hello. So this printf, and this cannot be recognized because I need to provide the header file, right? stdio.h. Either you provide the header file or you provide the declaration for this, right? So if you do with this one, definitely the assembly instructions will be generated, right? So as you can see, printf, call printf. So if you observe the statement call printf, printf is the function whose declaration is only available at this header file, but not the definition. This definition is available. This definition is available somewhere else in the library part, right? So there is a part of operating system called linker. Linker will link this printf with the definition, the declaration with the definition part. So even if you do not understand this, let me just tell you simply, printf function is something that you have not written, you're just using it. So someone else have written the code for this. So this printf cannot work by itself unless the operating system does not provide a support something called system call. So printf internally triggers a write system call. So unless the corresponding operating system does not provides you the write system call facility, you will not be able to perform the print operation, because you can clearly observe for each of these the assembly instructions are generated. So these instructions can be executed by your processor directly, right? So this is for x86. And if I go for risk machines, let's say if I generate for 64-bit risk machine, then these are the risk instruction. So let's say again, these these instructions can be executed by a risk machine or a risk processor. But if you observe this line number 15, right? If you can observe this line number 15, that is printf, this function is not available here, right? So this facility will be provided by the operating system, right? So as a programmer, you are able to use these kind of functions, or you are able to execute programs. So operating system is providing the facility, because whenever a program needs to execute, it needs multiple resources. It requires memory, then power consumption, processor time, right? IO devices and so on. So various hardware and software resources are required. So operating system acts as that interface to provide this mechanism by which your program can execute successfully without causing a lot of trouble. So the purpose of operating system is to provide an environment in which user can execute programs in a convenient and efficient manner. So imagine you just want to play a game. Before starting the game, you have to configure the RAM manually. Okay, you have to set from which address to what address, the address range the memory has to be allocated, right? When to deallocate which section of code. When, let us say, you're playing the game, you have to load the frames manually. When you fire a bullet, at that time you have to handle the code for firing the bullet manually, right? For displaying the graphics, you have to handle that part as well manually. So there is a lot of manual, or you can say a lot of hard work required and a lot of intervention required just to play a game. So in that case, the convenience is lacking there. And if efficiency, let's say you played a game for 5 minutes and your mobile battery dropped from 95 to 5% within, let's say, 10 seconds. So that is something is not expected, right, from an from an operating system. So one of the primary purpose is to provide convenience to the user, and next is provide efficiency. That means whatever hardware or software resources are there, that must be used in within within very tight limitations. It should be able to give you maximum output actually, right? So that's what the point, that operating system acts like an interface between the hardware and the user programs, right? Also we can say that it facilitates the execution of programs, right? So operating system is itself a giant software in itself. Again, this provides the base for other programs to execute, whether your web browser, let's say Chrome, or maybe Safari, or your media players, let's say VLC, or your latex editor, or the compilers, linkers, loaders, assemblers that you're using. All of these programs need the support of operating system in order to execute, right? So an operating system acts like a general manager. Like for any organization, the general manager supervises the activity of each employee or each teammate in the company. Similarly, operating system performs the task of supervising each component or each resource that is present in the computing system. So it also acts like a government. Like if you have a country might have multiple resources, let's say coal, minerals, ore, water resources, wind, air, airspace, and so many other resources. So if it is given open to public, then definitely things will get negatively exploited. So that is where government comes into the picture and handles this. So government utilizes the country's resources in effective manner so that maximum output can be generated, and most of the a majority of the public should get the facility or benefit of that. It should not be that a single person is getting the benefit of all the entire resource of a given country, right? Operating system also acts like a control program, because multiple programs are executing, right? So it should not happen that Chrome should steal the data from some game and bypass it through some other website. It should not be the situation. Let's say you're using Chrome, and through your system somebody else is accessing let's say some other program is running some spyware, and it is reading some data, and the operating system is not aware of that. So in that case, it is something that is not desirable, and we cannot compromise with that thing. So that is why operating system must act like a control program as well as a security manager, just to check that any other processes is not stealing, or any kind of data theft is not occurring while the execution of multiple programs. Okay, so a control program manages the execution of user programs to prevent errors and improper use of the computer. It should not be that you're playing one game, and when you start parallelly one more application, it should not say that the game must not acquire all the resources that is available in the system, right? So it is specially concerned with the operation and control of IO devices, right? So that's the idea. That means if I'm using this pointer on this browser itself, so this cursor, it should not be the situation that this cursor I'm not able to use in some other window. That should not be there, that this cursor or this trackpad which I'm using, this is only subjected to this particular window. It should not, when I click on the next one, the cursor should be able to I should be able to use the cursor in the other tab as well, right? So that is where operating system acts like a control program. Then again, it provides abstraction for hardware and manages resources. So here, for example, let's say this printf function is something which the programmer has not written. Somebody else has written this, right? So operating system provides you the abstraction. That means you need not worry as a programmer or as a user. You need not worry about the low level abstractions or low level details, like you need to know the circuitry, digital circuits, entire nitty gritty details, that how the data is transferred, how the instruction is decoded, okay, what are the various stages in pipeline that is happening during the instruction execution, how hazards are coming into the picture, how pipelining hazards are getting resolved. So this is something that user need not worry, right? Operating system and all the underlying hardware is supposed to handle this part, right? User need not worry about this, and that is where operating system plays a very pivotal role over there, right? Next, it multiplexes resources between different applications. So when multiple applications are being executed, so maybe one of the application requires printer, and at the same time another application requires the printer. So in that case, operating system has to handle this pooling part, that first of all application 1 will complete the task, and then next application 2 will get the opportunity to to perform the print operation, right? So again, so multiplexing of resources among different applications is done by operating systems again. So as a computer science engineer, why one should study about operating systems? Of course, to understand the resource management in better way, right? So let's say you're using an application, your application is under execution and there is some sort of trouble. So at operating system level, you should know how to handle the activity monitor, disk management tools, disk defragment tools, recovery tools, and various underlying concepts of operating system, so that you can understand that any process is poisoning the other processes or not. Okay, any process is there which is using the memory in an unfair manner, right? Then study about file and storage systems to understand that how files are stored, deleted, retrieved, or recovered, so you get a better idea regarding that thing. Explore concurrency and synchronization, that is, if you want to write multi-threaded programs in an effective manner, one should have a very good grip on these topics from operating systems again. Then understanding the security concept is again an important aspect if in operating systems, right? Then for programming embedded systems and all, and to have a better grip on system programming and understanding the underlying details behind the operating system and at the operating system level, so one has to be comfortable with the topics that are present in this particular course. And most importantly, when we say that I want to be Google good engineer. So in that case, you can observe this is the resource page, software engineering interview prep guide from Google. And if you observe here, definitely operating system topics are something that is definitely required. So as you can observe, context switching, right? Process, threads, concurrency, deadlock, live lock, avoidance, process and thread resources, memory caching, scheduling, multi-core concepts, and context switching. So these are the topics from computer architecture, computer organization, computer design, and as well as operating systems. So when you can observe that Google's career page is demanding this thing from a student, and that too again under the title you can see computing foundations. That means as a student or as a learner, these are the foundations that any company will expect from you. So that's why that is again very important point, that why one should be good with operating systems, right? So the topics at undergrad level that anyone should be comfortable with. So these are the topics already I have shown you within this web page itself. You can also explore by yourself, but this is little more detail, I can say. System calls, processes, threads, inter-process communication, concurrency, synchronization, deadlock, CPU and IO scheduling, right? Then memory management and virtual memory, very important concept, right? And then file management. So these are the topics that one should be comfortable with. So I hope I could convey myself that why operating system is such an important topic for any software engineer or any computer science engineer in general.